Well, hello, welcome back. We're going to look at two-dimensional arrays now and also ragged arrays. So let's go right to it and say, well, we might have data that looks more like a table than a list. So suppose we have 10 students who have taken 5 tests and we want in one of these cells to represent a test grade. So I'm going to say that each of these rows represents a student and each of the columns represents a test. So here's the Java declaration for a two-dimensional array of ints, two sets of square brackets, and we're going to pronounce this data type as int array array. So then when we allocate the space for the two-dimensional array, we're going to specify the rows first and the columns second. There's nothing in the language that says this is the rows and this is the columns, but that's the way everyone does it, so we're going to do it that way so people will work with us. These also are indexed from 0. So this cell in the upper left is all grades sub 0 sub 0. All grades sub 6 sub 3 is the 7th student and the 4th grade. So this is student 0, 1, 2, 3, 4, 5, 6, and test 0, 1, 2, 3. So that's where the 99 goes into this grid. It might be reminding you like that old game Battleship, and if you played that, that's good. That helps you get comfortable with two-dimensional arrays. The only difference is that we start counting with 0, and in Battleship they started counting with 1. Here's a way that you can allocate space for a two-dimensional array if you already have the data. It's similar to initializing a one-dimensional array, except we have nested braces in this case. So this array data has 2 rows, and each row has 3 columns. And if you type it out like this so that you can kind of see the grid shape of the array, then it's easier for people to look at. Okay, now we need a way of accessing the elements of a two-dimensional array. With a one-dimensional array, you just say, give me the length of the array. So what would it mean if you have a two-dimensional array and you say, give me the length of the array? It means the first dimension. So the number of rows, if you say all grades.length, you're going to evaluate to 10 in this case. And then for each row, we're going to look at each column. And now we need a way of saying how many columns are in this row. So we're going to say all grades sub rows length. All grades sub rows length. Read the dot operator as if it were possession. So all of the rows are the same in this case. All of the rows have 5 columns. All of the rows have 5 columns. I got mixed up for a second. So why do we specify the specific row and ask for the specific row's length? You won't know why until we do the segment on ragged arrays. But for now, this is the standard way of iterating through a two-dimensional array. So the inner loop happens first. That means that we've done one row, and then we go to the next row, we do each column, go to the next row, and do each column. And for whatever reason, I decided to assign every space in this two-dimensional array to the grade 88. So it's a high B, I guess. Well, you don't have to have just 2 dimensions. You might have 3 dimensions or more, and it gets harder to draw because 3-dimensional arrays are usually thought of as space, and we talk about X, Y, and Z instead of rows and columns. So if you think of this as a cube divided up into cells, like a Rubik's Cube would be a 3-dimensional array that's 3 by 3 by 3 in X, Y, and Z. That's one way that we can work with them and kind of still have in our head what's going on. When you go to a 4-dimensional array or a 5 or 6-dimensional array, then it's just very, very difficult. And people who work in 6-dimensional arrays typically do that all day so that they can get their brain around it. It's also legal to split up these square brackets. So this array called myLists is a 2-dimensional array of ints. And you might not like this, putting one set of square brackets on the left and one set on the right, but that's legal in Java, and it might be that the person declaring this wants to think of this 2-dimensional array as a 1-dimensional array of 1-dimensional arrays. I don't particularly like it, but I wanted to show you that you could do that, and some people do. Okay, let's look at ragged arrays, and as soon as I do this, then we'll go into Eclipse and we'll type some code that implements 2-dimensional arrays and play with some ragged arrays as well. So if your data happens to look like this, it's 2-dimensional, but it's not rectangular. So whatever this row of data represents, there are more of them than there are on this one. And sometimes these are extreme differences. So this one might have 100 elements in it, and this one might have 5. And if you were to declare a rectangular array here, you might be wasting a lot of space. So we want to be very specific about how many columns each row has, and that's a ragged array. So here's the code that would be used to declare this. Let's look at this line first. The data type is still the same. It's a 2-dimensional array, or int array. And the difference is when we allocate the memory on this line, we're only going to allocate this part. So we have a variable called ragged data, and it points to something that has 3 elements in it, and each of those 3 elements is a 1-dimensional array. So now ragged data sub 0, that's this cell right here, it can be assigned a 1-dimensional array that has 2 elements. Ragged data sub 1 is a 1-dimensional array of 4 elements, and this one is 3 elements. So what we started out, the picture that we started out with is here. That's the actual data that we've allocated. If we put ragged data sub 1 sub 3 gets 66, where does that go? This is row 0, this is row 1, column 0, 1, 2, 3, so a 66 would go here. You manipulate a ragged array exactly the same way as you manipulate a 2-dimensional rectangular array. So hopefully this for loop is starting to get familiar to you. The first dimension of the array, in this case 3, so ragged data's length returns 3, and then this time for each different row that we go through there will be a different length, but it's the same code as we had with the rectangular 2-dimensional array, and we decided to put 88 in every cell with the exact same loops. Okay, well, I'm not going to go to that summary yet. I'm going to go into Eclipse and we'll have a look at playing with these 2-dimensional arrays. Okay, so I'm working in a class called Hello World. I'm not sure why, but I had one kicking around here and it looks easy to use. So I think we called it all grades. And I'm going to do this in one step at a time so that you don't get confused between the declaration of the variable name and the allocation of the memory. So all grades gets new int and then two sets of square brackets, and we'll fill in them both. And I think I said I want 10 rows and 5 columns. Okay, it's really just that simple. I thought if you type it or see me type it, you'll believe it. Let's make some loops that will go through each element of this 10 by 5 array and put in 88 into each one. So nested for loops. The row starting at 0, row is less than all grades sub length, all grades dot length, and that's a property, not a method, so there are no parentheses there. And now we will make, what happened? Where did that come from? The inner loop, column gets 0, column is less than all grades sub row dot length. And we're going to say in all grades sub row sub column, put the value 88. It's pretty easy. Well, okay, it's easy for me because I've been doing it for a long time. Now I'm going to make the same set of loops, and I'm going to do system out print line. Oh, but this time I want just system out print. I'll put a space and concatenate it to all grades sub row sub column. And then after I'm done with that row, I'll do another print line. So do you see what's going on here? This print will put all of that row on one line. And then after I'm done that row, I'll go to the next line on the console. So what I should be doing is printing out a grid that is 10 by 5. Oh good, it worked. 10 by 5 88s. And set a breakpoint and walk through this if you're uncomfortable with it. It is really worth it if you're not familiar with how nested for loops work. This one must finish before the next iteration of the outer one, and walking through that either on paper or in the debugger is a worthwhile thing for you to do. So I promised you that we would go and play with ragged arrays in here, which are just a little bit more complicated. If you highlight a bunch of code and do Control /, you can comment it out. So I'm going to leave that there, and I'm going to, let's make a ragged array of doubles. So double two-dimensional array, and I'm just going to call it data. I don't know what kind of data it is. So data gets new double, and now we're going to specify the rows. I want 4 rows, but I'm not going to specify the columns, and this is the only way you can do it. You must specify the first one, and you must not specify the size of the second or subsequent ones if you have a multi-dimensional ragged array. So now what we have is we have the number of rows, but we don't know how long each row is. So data sub 0 I'm going to make that a one-dimensional array of doubles. And this one's going to have 3 elements in it. And data sub 1 is going to have 5. I could have made it 500 or anything, and I'm getting bored of doing that. Cut and paste is always a place where people introduce errors, so maybe I really should have kept typing. So let's put 6 there and 2 there. Okay, does that make sense to you? We have 4 rows, and this row has 3, and this has 5, and this has 6, and this has 2. The interesting part is that the looping, the two-dimensional or the nested for loop is the same. So I can uncomment that one, and now my array is called data. And it's a double, so I can put in 88.7. And I'm going to fix up my source. If you don't remember how to do this, here it is. Right-click, source, format. That looks much better. And walk through it in the debugger if it doesn't, if that's confusing to you. Maybe I'll print those out just because it's easy. So let's do SYSO control space, and we're going to do a print instead of a print line. Maybe concatenate a space in there so that we can see the individual numbers. See if that works. Okay, so we had 3 in the first row, and then 5, and then 6, and then 2. If you loop through an array and you put a constant here, it's wrong. You must ask the array how big it is, and if you're looping through a two-dimensional array, you must ask the two-dimensional array how long is this row that I'm working with. Okay, I think that's plenty to get you going with two-dimensional arrays and two-dimensional ragged arrays. You can probably figure out that if you really wanted to, you could make a three-dimensional array. And I usually demonstrate that using a smaller data type because these tend to get really fairly large. But in this introductory class, we don't spend any time on three-dimensional arrays. We just try to get you through two-dimensional arrays and an introduction to ragged arrays. Okay, let's just go back to the summary. Two-dimensional arrays are often called tables because that's what they look like, tables of data. And you can have higher dimension arrays, 3 or 6 or however many dimensions that you want. Multi-dimensional arrays also know how big they are. So they know how many rows they have, and they know how many elements there are in each row. So when you're accessing multi-dimensional arrays, you ask them how big they are. You don't put in constants. That prevents you from accidentally going over the end of the array. And we also have looked at ragged arrays in here, which are useful if you need them, if you've got data that has an unusual shape. That's it for now. You should be able to use two-dimensional arrays and figure out how to access them and watch the access of them in the debugger. That would always help. I'll see you in the next video.